Today's lesson is brought to you by the letter Q for quadratics. If you watched Sesame Street back in the day, you would know what I'm talking about. If you didn't, you have lots of time on your hands. Maybe, watch some Sesame Street. Just so you know, my writing hasn't gotten better, so there's that. You should be super pleased with it. It's just so fantastic, right? Like, haters gonna hate, you're gonna be jealous, but you know what? You can work through it. One day you can write this awful too. Okay, quadratic functions. Y equals ax squared plus bx plus c. Oh my lanta. All right, so we're gonna look at the 2 first on that squared here. So these are all degree 2 functions, right? We learned about these last year, lots and lots. Doesn't matter what class we were in. We got to learn about quadratics because they're just so darn fun, right? I know. So awesome. Okay, so if they're degree 2, they're an even degree function. And what's cool about even degree functions? What's cool about even degree functions is that their end behavior is in the same direction. End behavior is in the same direction. Okay, what else we need to know about is that we have this a at the front, which is still our leading coefficient. That didn't change. And I still probably can't write it well with this pen. Okay, it's our leading coefficient. Now, our leading coefficient tells us still how we end on the right. The only difference is that we're also going to end up on the left as well. So we end up on the right, but because it's an even degree, we're going to end up on the left as well. Okay. Then we have our c value at the back, which is our constant. Our constant is still our y-intercept. It didn't change. Because if we plug zeros in for our x's, the only thing left would be the letter without an x. Okay, so our constant is still our y-intercept. My pen is fighting me right now, not wanting to write. Okay. Now, we're going to look at an example. The example we're going to look at is y equals x squared minus 4x minus 5. Okay? Now some may say, well, what's my leading coefficient here? My leading coefficient here, if there isn't a number in front of that x squared, it's a positive 1. Okay? So I know I have a leading coefficient equal to positive 1. So what does that mean? It ends up on the right. And because it's an even degree function, it's actually going to end up on the left too, which is quite cool. Other thing we have to look at, minus 5, the constant. So we know we have a constant which equals negative 5, which means I have a y-intercept at 0, negative 5. Okay? Okay, if I want to sketch this graph, I need to find the minimum. I'll write it down here. Because it's concave up, I know they're up on both sides. So I need to find the minimum. How do I do that off my calculator again? So I type that equation into my y equals, and then I'm going to go second, trace, number 3, which is minimum. And then I'm going to follow the instructions. It's going to say left bound, so you need to be on the left bound of it and hit enter. And it says right bound, then you need to be on the right bound of the minimum and hit enter anywhere on the right. Then you hit enter again. Okay? If you're struggling with that at all, you can message me and we'll talk about it, okay? So we have 2 and negative 9 is our minimum once we use our calculator. Okay? The other thing we can do is we can go second, graph, and it pulls up our table of values, and that's where I'm going to get all the rest of my points from. So this is to get other points. This gets you your table of values. Gives you a whole bunch of x and y's that are on that graph. Okay? All right, now for the fun, sketching. Wish me luck. All right. Well, this is pain. Learn something new every day. Look at that straight line. Okay. So I'm going to go back to drawing. You know, I miss you guys. I also miss my smartboard. My daughter's at home with a cold, and so I'm not going anywhere because I don't want to spread her cold anywhere. So I'm here using this, but my smartboard is just wonderful. So I miss it. I miss you guys more, but I do miss my smartboard. Okay. So I'm going to plot the minimum, which is at 2 and negative 9. 1, 2, 3, 4, 5, 6, 7, 8. End of the line. Okay, 2 and negative 9 is my minimum. And then I know I have a y-intercept at negative 5. 1, 2, 3, 4, 5. Those are immediately things I know. I know I have negative 5 is my y-intercept because my constant's negative 5. Then I go to my table of values and I pull off negative 2 and 7. 1, 2, 3, 4, 5, 7. Okay, negative 2 and 7 was on my table of values on my calculator. And then negative 1 and 0 was on my table of values on my calculator. And then 0 and negative 5, 1 and negative 8. Okay. 3 and negative 8, 4 and negative 5, 6 and 5 and 0, 6 and 7. So, and then I'm going to try and connect these and round them because it's quadratic. Oh my goodness. Yeah, that's that's not even as bad as I thought it would be. Okay, that's not too bad. So let's check and see if what we said is true. Okay, we said y-intercept at negative 5. Which is true, right? Y-intercept at negative 5. We also said because the leading coefficient is positive, it ends up on the right. Boom, it does. And because it's an even degree, it also ends up on the left. Boom, showing all of that. The last thing we have to go over is domain and range. So the domain of every polynomial, unless it's a word problem, is XER. So that's easy. X such that x an element of the reals, and the squiggly bracket means the set of numbers x such that x an element of the reals. My range, because this one is at -9 or greater, my range, the lowest this graph goes to is -9 or higher. If my graph was concave down, it would be less than or equal to my maximum. But because this one's concave up, my range is going to be y such that y is greater than or equal to -9. So with quadratics, you don't get a range of YER like you do with linear, and you're going to get with cubic, okay? Now the end behavior, if I went to describe the end behavior of this one, I would say up on left, up on right. That would be how I would describe the end behavior. And a couple of examples. So same thing as before. We're going to follow the same pattern for all three of these types of graphs. So example. Given the graphs of the following, determine the sign of the leading coefficient and the constant of the equation. Y equals ax squared plus bx plus c. Question A. Are you coming to say hi?
Yeah.
Oh, 1 second. I'm going to let you see a picture of her. My daughter's come to say hi. Oh, I'm wandering. Can you say hi?
Hi.
Did you tell? I told them all I missed them. Do you think I missed them?
Yeah.
Yeah.
Because you were sad.
Yeah. Okay. Say bye.
Bye.
Okay. I'm going to finish my lesson. Go. Okay, see you, Isla. Go. Love you. Cool. All right. So we're going to look at A. She really wanted to come in on a video, so I told her she could. She is right. I was sad. Still kind of sad. But everything will be okay. You'll just get to listen to me by myself. So please message me at some point, because, man, I am boring. All right. Boom. We have our graph showing. Now I'm going to put a quadratic on that graph. It's going to have a y-intercept of 8. And it's going to be concave down. So we're going to cut through here. We're going to go something like that. Okay? So I know I have a y-intercept at 8, and that y-intercept gives me my c, my constant, right? So I have a y-intercept at 8, and so my c equals 8. And then how do I end on the right? I end down. So I know my leading coefficient is negative. Back to kindergarten writing. coefficient negative. My leading coefficient is the a variable, so a is less than 0. Boom. Okay, let's look at another one. B. Okay, this one has a y-intercept of 4. And it's concave up. Let's pretend that's symmetrical and through 4. Okay. So we have a y-intercept of 4. Wow. 4. So C equals 4. And it's up on right. So my leading coefficient is positive. Positive. So what does that mean? That means A is greater than 0. Okay, one last thing to go over. Possible number of x-intercepts. Boom. Ooh, bad lining. So, with quadratics, we can have two x-intercepts where it passes nicely through. Okay, we can have one x-intercept where it goes up to the x-axis, touches it, and comes back down. That looks like 2, but it's 1, pretend. So it's called a point of tangency, which means the vertex is on the x-axis. So that would be one x-intercept. Or we can have none. Or it could be completely above. Or completely below. Right? So you can have 0 x-intercepts. Degree 2 are the only even degree we're going to look at. And so because their arrows are in the same direction, their end behavior is in the same direction, they are the only ones that you could get 0 x-intercepts for. Linear will pass through at least once, and cubic, which you're going to see in a second if you continue to watch these videos, will pass through at least once as well. But so quadratic's the only one who has 0 x-intercepts possible. Okay, but then they could have 1 or 2. You can have the same amount of x-intercepts as your degree or less. Even degree functions can have 0, 1, or 2, or up to their pound. But odd ones have to have at least 1. Okay? So, once again, I will podcast the cubic function after this if you want to continue watching.